Mm-hmm. Hello, Raimund, are you there?
Hi, Marion.
Yes, wonderful. Hello.
Hola, and
good to see you. We are in the
good to see you too.
phase here. So you can actually see us.
I do see you, albeit a bit blurry, and I hope you can see me and hear me.
So I would announce Raimund Bleischwitz, the director of the Center for Marine Tropical Research in Bremen, my institute. And Raimund will talk to us on the role of systemic innovations to support transformation. So that leads us very well from the World Cafe type of discussions we just had. Now, let's try to have the screen shared. Would you compartir? See?
I can see you perfectly.
Yes.
It looks all amazing. Not applaud on presentation, but thanking technology, those who make it work.
Super. So we're looking forward to your talk, Raimund.
Then thanks a lot, and hola, one here in the room. I'm delighted to talk with you about the role of systemic innovation to support transformation, which I understand is a bit like a door to all the other presentations that follow. Eat the Invader. Plus, I see you have a very tight program with field excursion activities. So I very much hope we can have a good conversation, and no worries if you might have difficulties to follow. There's also an upload video on the presentation, which you might have a chance to look at a bit later. So let's go forward here. And I probably don't need to introduce the Leibniz Center for Tropical Marine Research here, if that Marion is also with you, Marion. But just to say that our institute works on tropical coastal ecosystem, in particular mangrove forest and coral reefs, but also at the interconnectedness of those ecosystems, at the impacts that come through climate change, and we also try to work on solutions. So how are people impacted? What can people do to develop response strategies? And there we are. Timely for the COP30 happening in Belém in Brazil, which has started the other day. So what is happening there? Let's just share that the current emission trends are risky. We are on the verge to overshoot the 1.5 Celsius target that was set by the Paris Agreement 10 years ago. On the other hand, back then, we were all overshooting much larger. So the ceiling that we have is a bit coming closer. And when we look at the current pledges that were given by the governments around the world, we seem to be close to be able to limit global warming to slightly above 2 degrees Celsius target. So that still is a challenge, but to me, that looks like one that we could manage together. So, however, we look for a booster with a long-term perspective that is needed for both mitigation and smart adaptation. And the issue of food is indeed key for both and for livelihood. There's a nice report that will be launched the other day in Belém at COP30, to which I could contribute. So just look at the Ocean for Life report that will be launched by the Forum for Development. All right. So why are innovation important? And you would really think innovation has been key for history and for mankind, for humankind, for decades, if not century. What distinguishes us from the Middle Ages, from the Darker Ages, from previous time, is by and large the ability not just to develop innovation, but also to absorb them. That has helped with literacy, with all the many other conveniences that we can enjoy. But it is important to not mainly look at single innovation, that is even a mistake, but to look at it from a more systemic perspective, to be able to connect the dots. That is very much the saying of the blind man and the elephant, where we need to look at systems of provisioning and delivery and think about it in the realm of food. So it's not just the single agricultural type of innovation, but the system of provisioning for food. So that leads us to a topic that my colleague from Fermoy, years Mariana Mazzucato, has brought up, the mission-oriented innovation, where we need some targets, science-based target, including biodiversity targets, the SDGs, and then develop shared missions together for it. So to me, the key is that we need to look at technologies, yes, but to embed those technologies in a socio-cultural understanding of innovation. And indeed, we need to look at institutional innovations too. So that indeed has been discussed in the food sector. There's a very nice recent report by FAO, or people working for FAO, where they have been doing an exercise that is called horizon scanning. So you look to the horizon and then you involve lots of experts to scan what is coming up over different time frames. Here they have been choosing 5 years, 15 years, or beyond 15 years. So they really try to look ahead for quite some time horizon. And then they look at the value chain of food production and a range of innovations that come up basically everywhere. So their conclusion in a way is that there is no shortage in innovation, but as we know from a minute ago, we need to put it together to see the broader perspective. What is lacking there in this report, as a minor thought here, is that indeed a systems perspective would need to dig deeper. We would like to understand better the socio-cultural dimension, the institutional dimension, and that is certainly something that you see on the right-hand side here on the slide, where those issues also need more emphasis. And that leads me to a bit of a dose of theory. There is a theory of transition management that is a kind of the mainstream of understanding changes and innovation in a couple of areas. It is very strong, in particular in energy. And you may think that is complicated, that graph that Fragils has developed a long time ago, but it's actually not too difficult. So it's multi-levels in innovation itself. So you have a larger system, but you also indeed start at the very bottom. That's what they call niche innovation. And then indeed, this is in particular relevant in food because you have such an enormous amount, such a high number of farmers and others who could potentially innovate. So the number of producers in the food sector is considerably larger than you have it in other areas. Say, think of automotive, where you have just a few suppliers in the world. But indeed, this system was shaken up, as we know, by Tesla a few years ago. So it starts with single innovation, and then they develop. Hopefully, they find early adopters that would purchase those novel products. But then what we see quite often is that they hit the ceiling of what is called the socio-technical system, the regime that consists of the existing culture. What food habits do people have? Or of policies or standards or permission processes. So that actually is hard to cut through. So we need to really think harder or in a more systemic understanding how those early adopters could become stronger and ask the question, what could happen if local and regional innovations could interconnect and pull strengths together? How would Blue Food living labs be able to really bring up a critical mass of both producers and consumers? And to understand those things, I would believe that transition management is a helpful underpinning, but indeed, we also need to understand the practicalities, right? So what is happening out there? Food innovation, as I said, is around. It has been scanned. Some innovation that I wanted to shed quick light on algae. So there's a lot that can be done with algae. They can be eaten. They have quite precious nutrients that make them valuable for human health. And if you wanted, you could also produce some materials with them. So that indeed is a quite interesting pathway that could be explored. Then I'm not saying much about Eat the Invader, but I would also consider it a very strong pathway about which we will hear more in a minute. What I find highly interesting also is aquaculture. You will probably know that these days more fish is produced by aquaculture than it is by wild fish catch. So it has become a strong, say, industry or strong system worldwide. And one of the perspectives that exists there is to have more circularity, because aquaculture could also be unsustainable for a number of reasons. But what if the feedstock could come from food waste, so there's more circularity and sustainability in it? And what if the energy that you see in particular in the more industrially oriented aquaculture is generated by clean energy technology? So there are ways of not just growing aquaculture further, but also making it much more sustainable. And the Leopoldina Academy, which is a national academy for science in Germany, has recently released a statement exactly in this direction, which you may find interesting. So just looking a bit more at the water, energy, food nexus here. So with the shift onto offshore renewable energies, you could also imagine a whole system where this offshore renewable energy could also be combined with a much needed low trophic aquaculture, so that there is a nexus between food and energy here that could also help with some, say, water issues if done, say, in rivers. Taiwan, the country, is also experimenting with floating photovoltaic and aquaculture, has made some good experience in it in pilots. So that could be one of the things to consider. And just to mention, a dear colleague of ours, Gesche Krause, has just published a fantastic paper together with others on regionalization. All right. So the final thought that I would like to leave with you goes in this more systemic direction, but also responds to us here, me being in Germany, others coming from Germany, you being in Brazil. So what if we had those innovations happening in Brandenburg and other parts of Germany, other parts of Europe or the world, and in Brazil? I really believe there's much that we could develop further in regionally interconnected systems of innovation. And that complements the stream that we have thinking of innovation systems as somewhat national. Yes, okay, that is an option, but especially in food and with global food value chains, we could also think of regional innovation systems that are so essential for food and connect them. So Brazil and we all together could be able to connect the dots. We could experiment decentrally and together. We could test, we could compare, we could assess, and then take the promising cases and pathways and ramp them up. So that would combine the strengths and weaknesses of a larger partnership. We could use the Eat the Invader idea as a starting point, and I'm certainly encouraging all students in the room to consider it as a potential area for thesis, be it master or bachelor or PhDs for startups that could be emerging, and indeed for the type of system innovation. As a last, more academically oriented thought here, there's a Lancet Commission on healthy and just and sustainable diets that has just released a report. And what you would not be surprised to see me concluding with is that they do have this systemic approach and a number of actions that could be done in order to become more sustainable, more just, and more healthy. I'm concluding here. Thank you very much. I'm around for any feedback question, and I indeed look forward and I cross my fingers for a successful being together on your side. Thanks a lot.
Thank you very much, Raimund. It linked to a lot of the discussion we've had, and I would open for questions, if any, or points. That not being the case, I'm myself really enthusiastic, but we haven't actually talked about some of the innovations, so that will happen now, to take up your points on how to go on. Yeah, well, at the moment, it looks like we are in the post-lunch phase. So I definitely
All right.
expect the discussion points to come up. We've had a very lively World Cafe and then eat the Invader lunch.
That sounds really great. So I'm really thrilled to be with you, and I hope to come the after lunch fatigue that some of you may have. And indeed, just be aware of me being so Marion or I share my email address, and you can call me anytime later on if you want it.
Thank you very much. So we are here in our program with Clara, who will start talking about the lionfish as our invasive species of focus.
Yeah. So Clara is a Brazilian researcher. She worked in the last 5 years on Fernando de Noronha with the lionfish management for ICMBio. And now she's doing her PhD at the Federal University of Rio Grande do Norte.
Clara, do you want? Yeah, let's stay better for the YouTube stream if we're up here. We're not trying to raise ourselves, we've been told.
Hi, everyone. I think Lena introduced myself quite well. My name is Clara. I'm a marine biologist, and I'm starting my PhD with the lionfish at Fernando de Noronha, but I'm helping ICMBio and IBAMA building the program of management of lionfish. I have 2 videos of Fernando de Noronha before the presentation to give you some point of view to understand what we talk about. Pode dar play nos vídeos. São vídeos bem curtos. Para ver direito, né? A lot of lionfish. And this is at 50 meters, 50 meters de profundidade, 60 meters. This is the first video. A lot of these lionfish invaded species. Thank you very much. This is what we say. This is a recent video from technical scuba divers. You can put the other one. It's a lot of them. The same thing. A lot of lionfish all gathering around. Eat our and then oh my God. Yes, this is Fernando de Noronha, a marine protected area. So marine protected areas protect from many insects, but not from invasive species. We try a lot. And the point of my lecture here today is to talk about of these first 5 years of invasion. In 5 years, we see this kind of scenario. And I feel more comfortable to talk in Portuguese. I think most of the people talk Portuguese. So I ask kindly to one help another if you don't understand something. Pode colocar a apresentação. Eu tenho muita coisa para falar. Em 5 anos a gente fez muita coisa em relação ao manejo do peixe-leão a nível de Brasil. Eu acho que nos 3 pontinhos tem, tipo, ver tela inteira. Não. Boa. Perfeito. Obrigada. Ótimo. Ah! É que baixou várias vezes. Ok. Os slides estão parcialmente em inglês, algumas coisinhas ficaram para trás. E se vocês não entenderem, a gente vai perguntando, conversando. Eu vou tentar falar bem rápido, porque o conteúdo 5 anos parece muito pouco, mas para o peixe-leão, assim, o bicho é sinistro. Eu tenho uma fala bem informal também, então às vezes vai ser difícil de sinistro. Wild. So this presentation is divided in these 4 topics. Primeiro, apresentando rapidamente a espécie, né, the Lionfish. Depois, explicando rapidamente o processo de invasão do peixe-leão, como que ele chegou até o Brasil. E aí vamos entrar na parte mais importante da palestra, que é falar sobre o manejo, a pesquisa e o envolvimento da sociedade, enfrentando a invasão dessa espécie exótica, e as perspectivas futuras sobre o tema. Bom, rapidamente, então, quem é o peixe-leão, né? O peixe-leão é um peixe da família dos peixes escorpiões, né? Tudo ali do reino animal, porque ele tem esses espinhos. Aqui é o pointer, né? Ele tem esses espinhos em cima e embaixo, totalizando 18 espinhos peçonhentos, né? Ou venenosos, mas o termo correto é peçonhento. E a gente tem no Brasil 3 espécies de peixes escorpiões também. Então isso já quebra um pouco aquele mito do peixe-leão, aquele peixe venenoso, né? Porque nós temos peixes que a gente chama aqui de peixe-pedra ou peixe-aniquim, né? Que são peixes da mesma família, tão peçonhentos quanto. Né? Então, já quebrando um pouquinho o estereótipo do malvadão, que é o peixe-leão, para os seres humanos, né? Ele é mais malvadão para as nossas espécies nativas. Ele tem esse corpo bem característico, listrado de vermelho e branco, pode variar, ele pode ser mais escuro ou claro, dependendo do ambiente que ele ocupa. E ele batemos o recorde no Brasil em Fernando de Noronha. Até pouco tempo atrás, o maior peixe observado tinha 47 centímetros, e agora nós já temos um novo recorde de um peixe de quase 50 centímetros, 49 centímetros e meio em Fernando de Noronha. E os peixes que estão invadindo o Brasil, por enquanto, é só uma das espécies, mas no Caribe nós temos 2, que é o Pterois milis e o Pterois volitans, principalmente o volitans, mas eles se parecem muito entre eles, só a genética para diferenciar qualquer um e qualquer outro, e eles hibridizam também, então em alguns lugares do Caribe já tem misturinha desses 2. E quais são os principais impactos do peixe-leão, né? O que torna ele um ótimo invasor? Igual o rato, igual o gato, igual as nossas espécies terrestres que a gente já enfrenta aí há 500 anos. Ele ocupa diversos tipos de habitat, né? Então ele está em foz de rio, manguezal, banco de grama marinha, recife raso, recife profundo, ele chega até 300 metros de profundidade. Então é um peixe que realmente ocupa todo tipo de habitat. Ele tem uma reprodução contínua, mensalmente o peixe-leão pode depositar até 30 mil ovos. Então, assim, a fêmea está sempre liberando bolsas e bolsas de ovos, e a fecundação acontece na água, né? Então, esses ovos fecundados ainda são carregados pelas correntes. Ele tem esses espinhos venenosos, ele preda qualquer coisa que couber na boca dele, então ele pode comer até 20 peixes a cada meia hora. Isso foi experimentos feitos em aquário. E tudo que cabe na boca dele, mais ou menos 75% da alimentação do peixe-leão é de peixes e 25% mais ou menos crustáceos. Camarãozinho, caranguejinho, ele come também. reprodução de até 30 mil ovos por mês, e ele pode viver até 15 anos na natureza, ou seja, sem predadores naturais, inclusive, ele vai só se reproduzir, colonizar novas áreas, e se a gente não fizer o controle dele, ele vai viver aí 15 anos só aumentando sua população, sem ter uma redução. E os principais impactos, então, que ele causa por ele ser essa espécie tão um ótimo invasor, né? Ele atrapalha nossas cadeias alimentares aqui do Brasil, então ele está predando espécies nativas, competindo com outros peixes que ocupam ali uma mesma posição que ele, que comem as mesmas coisas que ele. Ele acaba modificando hábitats ao longo do tempo, causa a perda de biodiversidade, então, às vezes, ele não causa extinção de espécies, mas existe uma grande perda de densidade de indivíduos, né? Então, você tinha um monte de uma espécie, agora você começa a ver só um pouquinho de alguns peixes que antes eram abundantes. Ele pode trazer com ele patógenos, parasitas novos podem ter vindo com ele, enfim. Compete por espaço e preda nossas espécies endêmicas, né? As espécies que só ocorrem aqui. O Brasil, para quem não sabe, é a província, em termos globais, a gente é o lugarzinho mais pobre em espécie de peixe marinho. Em comparação ao Indo-Pacífico, que tem quase 4 mil espécies de peixe, o Brasil tem 300 e pouca, quase 400, né? Então, é muito pouca espécie que o peixe-leão está aí comendo. E uma atenção aqui, esse dado tirado da IUCN, que espécies exóticas invasoras estão entre as principais causas de extinções de espécies ao redor do mundo. Então, tem algumas espécies que foram extintas da natureza exclusivamente por espécies exóticas invasoras. E espécies exóticas invasoras, junto com algum outro tipo de impacto, tipo perda de hábitat, mudança climática, também são responsáveis pela extinção de mais de 50% das espécies que a gente tem registro até hoje que já foram extintas. E qual é o processo de invasão no Brasil, né? Da onde que ele veio e para onde ele vai? Teoricamente, a invasão do peixe-leão ele começou mais ou menos aqui na Flórida, na década de 80, por soltura de aquário. É uma espécie muito cobiçada por aquariofilistas, e aí alguns foram sendo soltos na natureza. Tem a teoria do furacão Andrew, que passou também, mas o furacão foi em 1992. Ele pode sim ter liberado alguns peixes-leões no mar, mas principalmente desde 85 a gente já tem registro dos primeiros peixes aqui no Atlântico Norte. E aí, como vocês podem observar, é isso. Ele encontrou condições perfeitas para ir ocupando, né, a costa. Eu não sei se esse mau contato tem solução. Ele foi colonizando, chegou no Caribe mais ou menos em 2009. E em 2020 ele já estava no Golfo do México, Caribe, já estava aqui no Atlântico Sul, na Venezuela. Bom, aí começa a história do peixe-leão no Brasil. Em 2013, um grupo de pesquisadores, incluindo o meu orientador do mestrado, o Carlos Ferreira... One second, please. Obrigada. Em 2013, um grupo de pesquisadores começaram a se perguntar quando e o que faria o peixe-leão chegar no Brasil. Né? Então, coisas que dificultaram o peixe-leão chegar no Brasil, porque desde 2009 ele já estava chegando no Atlântico Sul. Mas o que dificulta? A corrente do sul do Atlântico, que olha o movimento, ela vem da África e sobe em direção do Caribe, não desce. Para algumas espécies de peixe pequenininhas, com dificuldade de locomoção, isso é uma barreira física, o peixe não consegue nadar contra a corrente. Um atum consegue, um tubarão consegue, mas o peixe-leão, que tem aquele formato todo diferente, às vezes não consegue. Outra coisa que dificultou também a passagem do peixe-leão aqui para o Brasil foi a pluma do rio Amazonas, que forma uma língua que avança para dentro do mar quase 100 quilômetros. E isso é, assim, uma barreira física que impede a passagem de peixes aqui do Atlântico Norte para o Atlântico Sul. Mas, ao longo do tempo evolutivo, geológico, os peixes eles vão chegando aqui. A maioria dos peixes que a gente tem no Brasil, eles vieram do Caribe ao longo do tempo. E a gente tem aqui na Foz do Amazonas, a gente tem esse conhecimento desde a década de 70, mas mais recentemente tivemos acesso por CUVs, né, câmeras submarinas, desse grande banco de recifes profundos, que não é aquele recife de coral todo coloridinho, mas são recifes de algas calcárias, de organismos bioconstrutores, né, que formam essa rede aqui, mais ou menos 70, 90 metros de profundidade, e os peixinhos, ó, esse aqui a gente chama de olho de cão, mariquita, dependendo do lugar do Brasil que a gente está, eles colonizam essa área e usam como trampolim, né, ou stepping stones, né, ou eles vão colonizando e usam aqui, param aqui, se reproduzem, se alimentam e chegam no Brasil, né, por baixo da pluma do Amazonas, e foi assim que o peixe-leão chegou aqui. Em 2015, 2016, nós tivemos os primeiros registros de peixe-leão no Brasil, mas não foi no Norte nem no Nordeste, foi lá no Sudeste, em Arraial do Cabo, quando mergulhadores observaram 2 indivíduos de peixe-leão em anos diferentes, mas, por sorte, temos grupos de pesquisa que trabalham lá, né, os mergulhadores, por conta de conhecer todas as espécies que ocorrem no local, né, viram esse peixe diferente, avisaram o grupo de pesquisa que trabalha lá em Arraial e falaram, ó, tem um peixe diferente aqui. Eles logo prontamente coletaram os espécimes, identificaram, viram que os peixes coletados no mergulho eram os mesmos que eles capturaram por causa do padrão de manchas, que é praticamente igual à nossa digital. E aí, isso foi uma atividade de prevenção bem sucedida, né? A gente detectou precocemente o peixe-leão, retirou e nem deu tempo dele se reproduzir. E provavelmente isso aqui foi soltura de aquário também. A genética desse peixe é a mesma do Caribe, que já mudou um pouquinho em relação ao Indo-Pacífico, que é da onde o peixe-leão é. Mas o Caribe produz para aquário também e vende para aquário. Então, provavelmente, esses peixes entraram ilegalmente no Brasil, porque é proibido a importação de peixe-leão, e foram soltos em algum momento, porque é muito estranho ter aparecido no Sudeste e não ter aparecido em nenhum ponto da costa em 2014, 2015. Em 2018, por conta disso, o ICMBio, que é o nosso órgão de manejo e gestão das nossas unidades de conservação federais, já incluiu o peixe-leão dentro desse guia de orientação para manejo de espécies exóticas invasoras em unidades de conservação federais. Então, desde 2018, antes da confirmação da invasão do peixe-leão no Brasil, a gente já tinha ali um resuminho sobre a espécie, sobre o que vem sendo feito no Caribe, no Mediterrâneo, onde o peixe-leão também invadiu. Então, a gente já tem muito conhecimento sobre o peixe-leão e a invasão dele, que é a invasão mais bem estudada, a invasão marinha, né, no mundo. Então, a gente começa usando esse conhecimento como base, né? A gente não vai reinventar a roda. A gente vai ver primeiro o que outras pessoas estão fazendo ao redor do mundo e aí adaptar para a nossa realidade. E um marco muito importante também, antes da invasão do peixe-leão no Brasil, foi a elaboração dessa instrução normativa 06 do ICMBio, também válida só para unidades de conservação, né, que dita exatamente como que a gente deve lidar com espécies exóticas invasoras. Olha como isso é recente. Até 2019, não existia a nível federal uma regulamentação para manejo de espécies exóticas invasoras. Isso é tipo ontem, né? 2019. E aí, dentro dessa instrução normativa, ela explica como é que as unidades de conservação elas devem lidar com as espécies. A gente tem que escrever um projeto de manejo, falando como que a gente quer capturar, que tipo de petrecho a gente vai usar para capturar essas espécies, para onde a gente vai destinar essas espécies. Então, é tudo muito recente. E só em 2022 o ICMBio criou a Coordenação de Manejo de Espécies Exóticas Invasoras, a atual CEMEI. Gente, isso é ontem, é muito recente. E isso só para unidade de conservação. Fora de unidade de conservação, ou seja, o resto do Brasil inteiro, a gente estava muito ao léu, às cegas, sobre o que fazer com espécies exóticas invasoras, e estamos ainda. Bom, aí chegamos em 2020, o primeiro peixe-leão foi registrado em Fernando de Noronha, e como é Fernando de Noronha, tudo vai para a mídia, né? Então, peixe considerado invasor foi achado em Fernando de Noronha. Aí a gente começa a receber as fotos da galera da Foz do Amazonas. Esse peixe é invasor, a gente já estava vendo ele aqui, só não tinha conhecimento. O que a gente estava conversando sobre a educação ambiental também mais cedo, né? Às vezes as pessoas não sabem que é uma espécie exótica invasora ou não sabem que pode comer e solta, libera o bicho de volta no mar. Mas aí, a partir de 2020, então, a gente teve o registro oficial da invasão do peixe-leão no Brasil pela foz do Rio Amazonas. E aí a gente começa, então, a falar de pesquisa, manejo e ações com diversos atores que estão envolvidos e sendo afetados pelo peixe-leão. Né? Quais as ações rápidas, então, que a gente vai fazer? Olha, eu toda feliz. Primeiro peixe-leão coletado no Brasil, tadinha, nem sabia o trabalho que ia ser. Esse foi exatamente o primeiro peixe-leão. A gente estava aplicando dentro do ICMBio um protocolo de detecção precoce e resposta rápida, que também está naquele documento da IN de 2019. A pessoa, sabendo que tem uma espécie diferente ali que ela nunca viu, ela vai informar um pesquisador, vai informar o órgão governamental para ver se aquela espécie é exótica mesmo, para assim a gente poder capturar. E foi exatamente isso que aconteceu. A partir de então, isso foi em dezembro de 2020, né, véspera do Natal. A partir de então, 2021 foi um ano muito corrido em Fernando de Noronha, porque a gente começou a treinar as equipes de mergulho locais. A gente teve muita sorte, porque temos um brasileiro que atua no Caribe, o Paulo Bertuol. Ele coordena e é pesquisador da Estinapa, em Bonaire. Ele estava de férias no Brasil em janeiro, visitando a família, e a gente, Paulo, vem aqui capacitar a nossa equipe do ICMBio para que a gente possa multiplicar esse conhecimento e começar a capacitar os mergulhadores também. A gente começou a aplicar detecção precoce e resposta rápida, então foi um alerta. Esse é o peixe-leão, a gente bota a cara dele lá, faz todo mundo conhecer o peixe-leão, avisem a gente para a gente ir pegar. Criamos um guia estratégico nacional, consegui um edital do Ministério do Meio Ambiente para a elaboração de um guia de manejo focado para o peixe-leão, cartilhas para embarcações, cartilhas para distribuir para diferentes públicos, incluindo mergulhadores, pescadores e turistas. O nosso projeto de manejo da nossa unidade de conservação foi aprovado em novembro de 2021. Imagina se a gente não pegasse nenhum peixe-leão enquanto a gente ainda não tivesse o nosso projeto de manejo aprovado. Então, por isso que serve a detecção precoce e resposta rápida. Isso respalda a gente de continuar agindo, mesmo sem ter um projeto de manejo aprovado ainda. E integração do manejo com a atividade de mergulho de Fernando de Noronha. Quando a gente fala de Noronha, Noronha é um caso à parte do resto do Brasil, porque tem visibilidade ótima, mergulhadores técnicos que chegam até 120, 180 metros de profundidade, e mergulho todos os dias do ano, de manhã, de tarde e de noite. Isso não é a realidade do Brasil. A maior parte do Brasil tem uma água péssima de visibilidade, não tem mergulho, e a maior parte das populações afetadas são pescadores artesanais, marisqueiras, enfim, e comunidades tradicionais. Eu vou passar rapidamente a parte, isso tudo é do nosso plano de manejo, então a gente capacitou os mergulhadores, a gente visitou áreas intangíveis. Dentro de parques nacionais, o problema do peixe-leão é que a gente mergulha em pontos específicos do parque, mas todo o resto fica lá o peixe se reproduzindo. Então a gente organizava expedições para ir em áreas que nunca eram acessadas, fazíamos um protocolo de monitoramento embarcado, direcionávamos todos os peixes para pesquisa e confeccionamos os nossos próprios recipientes de captura e arpão, que não vende, né? Não existe esse tipo de equipamento para vender no Brasil, e nem esse tipo de arpão, que é um sling havaiano. Então, a gente confecciona os próprios equipamentos. Também, o estado de Pernambuco, atualmente, é o único estado no Brasil, falando fora agora do ICMBio, a nível estadual, o Pernambuco é o único estado que tem um projeto de manejo focado para peixe-leão. Isso foi feito em 2022. E aí, enfim, lançamos publicações mostrando o processo de invasão do peixe-leão. Ele já está aqui na divisa da Bahia com o Espírito Santo. Em 2024, continuamos o monitoramento em áreas intangíveis, capacitamos nossa equipe. Eu tive a possibilidade de capacitar também outras 23 unidades de conservação federais. Então, dentro de UCES, está tudo padronizado. E agora, né, a informação mais recente que a gente tem é que o peixe-leão está aqui na divisa da Bahia com o Espírito Santo, então ele vai continuar chegando, né, é provável que ele chegue até o Uruguai. E finalizando, né, então o que espera, gente? Dentro de unidades de conservação está tudo certo, mas e fora das unidades? Por que a gente ainda não está falando em comer peixe-leão, né, acessando comunidades tradicionais? Teoricamente, a gente não pode ainda comer peixe-leão, porque ele não está regulamentado como ele não está regulamentado como recurso pesqueiro pelo Ministério da Pesca, e o IBAMA ainda não protocolou nada sobre direcionamento do peixe-leão, subprodutos do peixe-leão, se pode cultivar em aquário, se pode criar para comer. E aí, há 2 semanas atrás, a gente teve uma reunião em Maceió, reunindo IBAMA e ICMBio, que já sabe muito sobre a invasão da espécie, e finalmente vai sair uma instrução normativa falando que é proibido criar peixe-leão para aquário no Brasil e vender. Quem já tem vai poder ter, mas não pode vender mais. E regulamentando a venda e o consumo desses subprodutos do peixe-leão. Mas o peixe-leão ainda não é um recurso pesqueiro, porque isso é o Ministério da Pesca. O IBAMA só pode falar que a níveis de manejo, fora de unidade de conservação, a gente vai poder comer e vender seus subprodutos, né? Mas, teoricamente, quando a gente ainda não tem regulamentação, é proibido. A gente acha que é permitido, mas, na verdade, é proibido. E aí é isso, são essas populações. A partir de agora, eu espero que essa IN ela saia no início de 2026, e agora a gente vai começar a trabalhar com realmente a população que está sendo diretamente afetada pela invasão do peixe-leão, e aí começar a comer, se alimentar dele, como é que é? Eat the invader and leave your native species alone. Então, a gente vai começar a fazer isso, biojoias. E eu achei legal, porque isso diz sobre o que a gente tratou na nossa World Coffee. A gente não faz nada sozinho, então sempre tem que estar integrado pesquisa, governo e sociedade, né? A gente sempre tem que caminhar junto. Não dá para pesquisador botar o pé na frente ou o governo pensar em planos que não se adequam à sociedade. É isso, gente. Obrigada. Eu tentei falar o mais rápido possível. Thank you very much. Thank you very much. And I'm sorry to speak in Portuguese, so it's a lot of information.
I hope that. Thank you very, very much, Clara. That was a really good introduction to the species and the threats that are being faced. And now we have Lena talking. Yeah, we have time for questions. We must have time for questions. Sorry. If there are any, there's a question.
We'd like to build that role in society. Last month, 100 fish per minute. They spent 1 hour at the night and caught 58 lionfish in one night. They used huge meters, nearly 2 meters, 1.8 meters, so different and full of life. Okay. And similarly, the average size with regard to meters, that includes like the head and but it's still quite big. Do you have the average size? They start to reproduce with very
We will still have time for over the next few days to put our heads together and everything. So, okay, I will continue with my talk. I don't. Can you set it up? Maybe? Or in the meantime, we still can have questions if you want to proceed. Because I wondered if I didn't find any monitoring program in Brazil so far, which is just keeping track of the population numbers. Do you know of anything that is happening in that concern? Yeah.
He tried to keep monitoring all the states, but people don't share their data.
Mm-hmm.
Mm-hmm. To keeping track of all the equations and the real numbers. We don't have that. In Fernando de Noronha, like this, and just this year they issued 2,000.
Oh wow. Okay. Yeah, Marcelo told me a few days ago 1,500, but I think you might be more correct, because if I see these densities, it's just like crazy. I've seen that in the Caribbean. I didn't expect it to be that bad already in Brazil. So I'm just kicking in exact the slot where Clara couldn't go with the ICMBio and with the officials. I just started to use the Invader in Brazil and promoting the lionfish consumption. We discovered that it is a threat for the fishers through my master thesis, like preliminary work in the region where we're going in the next days in Bragança, and we did with No Crisis project of Marion and other research institutes creative workshops, stop motion workshops with local communities to find out about their problem and broadcast it in a bigger way, like put it on social media. And what the fishers there identified at that time as their biggest problem was lionfish. So I did a quick research and found out there's basically no other way countering that invasion apart from commercializing and eating it for food security and also livelihoods in artisanal fishers and local communities. So at the end of the workshop, we also had a lionfish meal, and it was part of the video that we produced that you can eat it. So the social ecological benefits of lionfish consumption. So basically, the basis is that you have to do it in a non-sustainable way. So you have to fish more lionfish than you would do it in a native population, go beyond the maximum sustainable yield. And this way you can basically mitigate the pressure on the native species, because you as a human are taking out lionfish, which then are not consuming the native species, and you as a human will consume less of the native species. So this pressure is lowered a little bit. And you have the opportunity to eat eco-friendly fish, which is pretty rare nowadays. And lionfish really tastes good, as you just experience, I hope. So the different approaches of management have been explored in the past, as governmental programs kind of always failed when we were talking of programs that were paying compensation to fishers for each lionfish to get out, because all these funds are pretty much like in a few months they're gone, because there's a lot of lionfish, and if you pay a fisher $3 per lionfish, then you will run out of money pretty quickly. So what's now done all over the Caribbean and the US is to put derbies and tournaments into place. Just now in 2025, the biggest tournament in Florida, they expected over 20,000 lionfish in 3 weeks. And in Mexico, you have a little bit of a better stands because the consumption and the commercialization was pretty well done and powerful. So you have fisheries in Quintana Roo, in the Yucatan Peninsula, where you already collapsed the lionfish population, which you can see on the left side. Yeah, and it was, for example, governmental promotion of NGOs, of press like The Guardian or National Geographic, many scientists promoting the lionfish consumption and putting out lionfish cookbooks, as you can see, educational work and so on. So the regional challenges here, as Clara already mentioned, there are no ways of doing tournaments or spearfishing here in Pará or in many parts of Brazil because the water is murky and you don't have recreational diving or people who have the gear. You have to find other ways to get the lionfish out of the water. Also the Great Amazonian reefs, where you have already quite a big population of lionfish as well. It's extremely deep. And lionfish, like you already mentioned, can exist up to 300 meters depth. So then you have here the bycatch scenario. You basically get lionfish in on the coast of Pará just by traps of red snapper, or maybe sometimes, what's it called? Lobster. And then you have a closed season for red snapper. So then you cannot go out with these traps of the red snapper. So you would have to specify the traps to not have the bycatch of the native species anymore. And a team in Florida has done this with the Gittings trap. I put a link for a YouTube video on it where you can see how it works. And it basically really has low rates of bycatch. It just attracts lionfish through this structure in the middle they're attracted by. And then you can extract them, and you also can put a lot of traps together for the industrial fishing industry to have a little bit more effective. But these traps are pretty new. They're still tested, and yeah, the industry will have to put in some effort as well to just see how feasible it is to fish with those traps. And the other consideration, which is discussed like pretty heavily here in Brazil on the coast, is that you have contamination of heavy metals. But this counts for all the fish species on the higher trophic levels. They just put, or 2022, they put a paper out where they examined 30 species, and more than 2/3 of those had above legal limits of arsenic. Yeah. Yeah, and they are also contaminated with mercury, obviously, because of the Amazon influx. There are some studies from Florida which say that lionfish has less or is less contaminated with mercury than other species. But having a closer look at it, you see that also lionfish is the smallest fish on the scale that was measured here. And usually it is like this, that you have the size, the sex, and the habitat which are influencing the heavy metal contamination. So you have smaller, younger fish, and they're not as heavily contaminated as the bigger, older ones. The females are more contaminated than the males, and it depends on the habitat what kind of contamination they have. For example, here in Brazil, they found on the coast of Será and Piauí, you have a lot of artificial reefs, which the artificial part in is it's old wires and refrigerators, old cars, and just rubbish and garbage that doesn't belong in the sea. So there you have a pretty high arsenic contamination. And in the natural reefs, you have a higher mercury contamination in the lionfish. Also, what is to be considered, that people might start breeding and spreading the species intentionally to make money if you put a lot of money into the industry. But in my research, I have not found one example of breeding attempts of lionfish so far. I even looked up in forums of aquarists that were talking about they have never seen reproducing them in the aquarium, even if they had a big aquarium in various lionfish. And I also didn't find any reports of intentional spreads so far. So I think it's a consideration, and it's worth educating people that it is a threat and we want to get rid of it and not reproduce it more. But I don't know if it's a reality yet, at least. Yeah, and they have high natural recruitment rates anyway, so there would not be much sense in breeding them because they're breeding themselves pretty well in the wild. So our approach here, building up on the work that I've done in 2023, we wanted to organize workshops again, but this time, and also that have a creative part in it, but focusing more on the just on the promotion of eating lionfish and of bringing people together who can facilitate this. So we did workshops with the fishing industry. We did workshops with restaurant chefs and with food stall chefs. And the other part of the project we're in right now is this conference, because here we can gather local experts, international experts. We have the business part covered, and we're getting to Braganza, to the industry as well. And I would have hoped that there are some policymakers, but they didn't follow my call, as it seems. But as like Clara gives me a lot of hope when she's talking about this thing Ibama is coming out with right now. It's crazy that it's happening just now. So yeah, we're still in the middle of the project, and I hope we can find some solutions here. So this was the first workshop targeted at fisheries associates, like fish processing industry, local policymakers. And in the end, we were at a round table with GPesca, Abrapa. Like GPesca is a big player in Braganza, fish processing. They also have a lot of boats. Abrapa is a fisheries association. They control about 1,000 boats in Braganza. Going all the way up to Amapá for several weeks. We had the assistant of the secretary of the municipality of fisheries in Braganza, and we had one chef who was from the beginning pretty engaged in the project. When he heard about it, he was basically taking part of in all the workshops and finding out about recipes and promoting and advocating really strongly for the lionfish consumption since he has known about it. So yeah, we wanted to get everybody at a table and find out about the legal pathways to get lionfish consumption through. Also marketing ideas and possible product chains. And yeah, we started to gather ways of creating a legal framework. I had the idea of rebranding initially, but everybody said it was not necessary because novel food would maybe more be an asset, because people would be curious, and lionfish looks pretty amazing. So they said lionfish is a good marketing start. And everybody was convinced that we should get some celebrities and public figures to eat them on social media channel, and this would help. So now we're trying to partner up with local, with potential buyers, policymakers, and celebrities, and also using this conference as a platform. The second workshop was with restaurant chefs in Belém. One of those was Ricardo Nobre, who just gave us his lionfish show cooking experience. And we wanted to inform the people who could multiply and amplify the information that you can eat lionfish, and would start to create market demand for lionfish, and create recipes, and also create recipe video during the workshop, with which I will show you tomorrow. And what came out of it as well, they said that novel food was a selling point. Promotion by celebrities was also emphasized, and they said it would be really advantageous to do show cooking events at public places. Yeah, they will still advocate for lionfish consumption in the restaurant scene and also in their projects, because they are all connected. Chef Nobre has a project of exotic Amazonian food. Chef Oliveira Teng has a project on sustainable food. Lucas is an educator at Eschmack, where we could hold our workshop. And Alessandro is the chef that helped from the beginning to promote the lionfish and was also part of the other projects of the other workshops. We created like 5 really nice recipes. And have now an English and a Portuguese version of the recipe video that is published through the ZMT YouTube channel. The second workshop, culinary-wise, was with food stall owners and street kitchen chefs in Braganza. We had 7 women. One of the women was also married to a fisherman, and she was already telling in the workshop that she will inform her husband that he should bring lionfish from now on. Everybody was convinced that lionfish was a really good way of eating sustainably. They also liked the taste, so we had a really nice day preparing several meals. We also we got the information. Yeah, we did it at Usina da Paz. They also shared the project via their social media channels. We also produced a video here, English and Portuguese version, and yeah, they're super ready and excited to cook for you tomorrow in the evening in Braganza and to educate their personal and professional environment, which they're doing already. So lessons learned from these experiences here and from the workshops. Definitely it is an advantage to meet up one-on-one with the fishing industry partners, because a room full of businessmen is really hard to control in terms of having a workshop program worked out. So yeah, and at least 2 days for the culinary workshops, because it is really tight to create the recipes, evaluate them and talk about them, also have information about the lionfish passed through to them, and then shoot the video in the end of the day. And yeah, it is not really possible to have a fixed schedule during the workshops. And here arrangements and organization can be very difficult. Like it is to be expected that everything is going wrong, and you always have to find some alternative ways of organizing things, or of yeah, just being flexible in what you're doing, because the workshops also were planned in a different manner that they have been implemented then. So for the future, what we worked out, what would be advantageous, or which is already on the way, is a monitoring program which could work with citizen science. I'm talking to a woman from the municipality in Braganza, and she had the idea to put iNaturalist as an app, because yeah, it's already used for population estimations, and you could also use it for invasive species population estimation. Showcase cooking events like this you have just experienced. Getting out a booklet maybe of the recipes that we've created in the workshops. We are trying to reach the Beleng football team through some contacts, because they have the lion as a mascot, and maybe it would be a good idea to get them to eat some lionfish in the public. We hope to establish some profitable business partnerships here via Inversa and Akari Fish or Petsy Pets and the local fishing industry in Braganza. And maybe ZMT will develop further projects working on this topic here. And yeah, we hope that our videos will go viral here in Brazil. Thank you. Thanks.
Yeah, I guess
Yeah.
if there's some more information about the volume or something like the policy it's all related to lionfish, because I'm curious as fishers that go into the water.
Mm. They just recognized this was the initial way we got attention to this topic. They just realized they get more and more lionfish in their traps where there's supposed to be red snapper, and then you have a lot of lionfish in there. So, but this problem varies also with the season, they say, and they could not tell me. I already tried to find out about the capacity or about the quantity that they have in there, but it's really, really get like hard to get numbers out of people. I like the most reliable source that I had was someone from ICMBio who goes on the ships with the fishermen, and he said it's sometimes maybe 80 specimens per ship that is going out, which is not so much. And also the fishing industry in Braganza, their biggest concern is not to have enough for you or for a bigger scale like business partnership, because they don't really know how to extract it. Yeah. This is also the reason why I think it's super important to have a monitoring and also to work on the trap systems. No, I think we're. Okay. Lukas. Yeah, Lukas cannot be here. He's online. Yeah, but I don't think he's live online because he wrote me an email this morning or just now that he won't be there. It's a video. Yeah, it's pre-recorded. Yes. Okay. So then we have Lukas Bosch now speaking through video to us. He established a project in Germany, in Brandenburg, about invasive crab species and tried to implement basically the same ideas. They had a pop-up restaurant for a long time in Berlin, preparing these species. He also worked with invasive plant species, and they produce, for example, as well fish oil and also pet treats from this invasive crab. And now they're turning more in the direction of consultation for other companies to work with invasive species and are not the primary producers anymore. Yes. Do I have to put something more?
Hi, this is Lukas from HolyCrab. Yeah, I wished I would be there, would have been there in person with you. And I also would have wished to not only send you this video, but obviously if you see this video, the internet line doesn't work. So let's do this presentation quickly via video recording. Yes, for us, HolyCrab and the whole exploration of invasive species in the beginning was kind of really a fun exploration project, a fun design project, a fun utopia project, kind of. I want to share one thing out of these early kind of explorations of the topic in the beginning, because I always start a presentation with that. It kind of really sets the tone how we look at the topic. There are 10 plagues mentioned in the Bible. 4 of them actually are edible, what we found out in our research. And since we humans began acting like God, a few more have been added, but luckily some of them are quite tasty too. So that's exactly kind of the spirit we're looking with at invasive species. But the whole thing really began in August 2017 with this newspaper article that we kind of coincidentally stumbled upon in the internet, because we've been living in Berlin for quite some time before. So we're kind of curious and stumbled upon this invasive crayfish species that kind of spread in Berlin, developed a heavy overpopulation. It's a US-based crayfish, the Procambarus clarkii by its Latin name. Louisiana crayfish, basically known globally. And what we only found out later, when we kind of dove deeper into this species and the problem of invasive species, was actually that exactly this crayfish, the Louisiana crayfish, is the most cultivated in aquacultural ways, cultivated crayfish worldwide for nutrition and culinary purposes. So what kind of really became obvious to us is that there kind of really is this potential of maybe looking at this whole problematic definition of invasive species, of having no natural predators in ecosystems from a kind of a different perspective, by reintegrating as humans back into the food chain. I mean, we have been part of the food chain for most of our existence, but basically kind of detached ourselves from the food chain in direct purposes by industrialization in the past decades. What we kind of really found out in a more not only fun related but really more deep research was that, and you know all these facts already, but I'm just mentioning them as cornerstones for our development and our research into the whole sphere. That basically invasive species are among the 5 main reasons for this rapid mass extinction in the event, the biodiversity loss that we're facing right now. And they even also, this is like a very cornerstone for us in terms of how to kind of quantify and kind of really put the whole subject in relations, cause higher costs than many of natural disasters, which is something that kind of is overlooked so often. Kind of really worth to kind of focus the debate and the discourse of the whole topic more also on a really grand scale. But basically back to our perspective in terms of how to solve that big problem, and the motivation that arose from other research as well, was really to kind of dive deeper into that question of what do we really mean culturally speaking when we say there are no predators for these cultivated crayfish, popular crayfish species in Berlin, because we only can see them through a lens of nature protection, and obviously then they're only a problem. But they're a problem actually as many invasive species that kind of carry a probable solution within themselves, and the solution basically is us reintegrating ourselves back into the food chain. I mean, we're intelligent omnivores. We're kind of capable of seeing that ecosystems are suffering due to certain phenomena such as invasive species. So why shouldn't we not focus our own nutrition, our own craving basically for delicacies to that sources where we can really have a positive impact. And that's how we started out with a food truck in Berlin. We were lucky enough to meet a very nice, very passionate chef as a co-founder, who really helped us to kind of turn this idea into reality and to really translate the invasive species being like a plague as something that is kind of has a very negative connotation, being a problem for the most, into something that kind of really could people see and also taste as the opportunity that lies into that obstacle, basically, as the opportunity that lies into invasive species, as an interesting catch on how we can basically have an impact through very basic but very delicious consumption. Our idea was awarded by several institutions. We had a lot of press, basically for the idea, for the concept, and we didn't stop with the food truck. So we were kind of really fueled by very positive feedback as well, and collaborated with several very nice restaurants in Berlin and all over Germany, to kind of let us in their kitchens and cook with us, basically. And I just want to take you on a quick tour through one of the menus that we had there. A menu basically started, most of the menus basically started with the bouillabaisse from the Chinese mitten crab. It had a very lobster-like flavor, and it continued with nutria tacos, kind of street style or street food inspired dish, but really like finished in a high cuisine manner. Then we had the breast of Nile geese on some mashed potatoes and served with a very special herb sauce, basically consisting of 7 special herbs that are attached to the region where we sourced the Chinese the Nile goose from, to kind of reunite them on the plate in a new interpretation. This is also one of my favorites, and maybe a very debatable dish, or kind of seen in very different perspectives from different people. It's a raccoon goulash with some wild boar added, also from both coming from a hunter that kind of hunts in Berlin forests, so very locally sourced in that case as well. And we also kind of had a dessert, which was based on an invasive plant species, the Japanese knotweed, that we harvested ourselves in parks in Berlin, and cooked like a gelée from it, which kind of, if you add sugar to Japanese knotweed, it kind of really creates this rhubarb-like taste and sourness. So it was really nice to kind of combine it with the white chocolate. And well, this makes invasive species basically a 5-course and probably Michelin star level a menu. So it was really important to us to kind of showcase and highlight in a certain way that like one's problem can be another one's solution, basically, to kind of keep it on the old saying, that you can turn an obstacle into an opportunity. It's just a matter of the perspective that you shed on the topic. Well, and then something happened to our gastronomy-focused business that kind of we hadn't foreseen until that point. It was the pandemic, and we kind of really had to apply this perspective once again to kind of find opportunity into a situation that was very much looking like a big problem for a very young business, just opened doors 1 year before the pandemic. But we kind of really also found something in this situation that, looking back at least, was like a huge game changer for us in a positive way. We had to shut down all of the restaurant-like operations, but found the time to focus more on creating products, retail products from invasive species. We had a great collaboration, for example, with a startup also based in Germany, and produced several essences and fonds from Chinese mitten crab in that example, but also from crayfish, also from different invasive fish species. They're basically cooked for 24 hours and refined with some spices and some other ingredients, vegetables, to give it like a fuller taste. And then they have a shelf life of at least 2 years, so it's a very nice product for going into retail. We've been even like as we can see on the photo in a very prestigious culinary department of maybe the most well-known shopping mall in Germany. And this is kind of a very iconic image, at least for us at the time, because we really kind of realized that we made it, that we kind of turned invasive species into a delicacy that is able to be sold in these kind of spheres of culinary life, specialized products in delicacies. what happened afterwards is also, looking back, a very interesting episode of the company, of the startup history that we have lying behind us. Because in 2022, or already in 2021, we got approached by the Berlin Senate to take over the fishing practices, to kind of really be part of the management strategy for invasive species of Berlin. And we got the license, the fishing license, for several park waters, lakes and parks. Employed 2 fishermen, actually 1 fisherman really coming from the coast, and the other one, Daniel, was more has a background in biology, so really was also very, very fierce on the scientific exploration of the topic. And we learned a lot in that time as well. And well, with regard to the time, but also with regard to basically an outlook of what happened since then, and what we're about to kind of prepare right now, I want to quickly use the time to zoom out and reflect a bit on what we've learned on that journey as founders who didn't have a background in nature protection, and also didn't have a background in the culinary field. So back then when we started, but really probably went to the topic with a naive perspective, but also focused on transformation, because we did that in our roles as business consultants years before. And we're still also running a business and sustainability consultancy focusing on product development and business model development. So this was basically also in this regard like a field study. And one of the biggest takeaways for us is really this shift of perspective to say, well, obviously it's a big obstacle to healthy ecosystems, and to also bring the biodiversity loss to a halt. And to kind of face all these invasive species. But on the other hand, we have a big opportunity to kind of really change something within food value chains, where a growing number of consumers is asking the question, where is my food coming from? How healthy is it for me? How healthy is it for my ecosystems? And to really bridge that gap between nature protection and the food industry, basically. And this has also a lot to do with how we think about and live sustainability, meaning not in this kind of very Protestant notion of abstaining from everything, abstaining from flying, abstaining from eating certain foods, and basically having the feeling of having to kind of let go of everything that sounds like fun, which doesn't have to be the case if you look to it closer, right? If you can eat invasive species, for example, these Louisiana crayfish, and basically do good by eating them with regard to the ecosystem, because you support a fisherman that kind of really takes care of managing these invasive species that would otherwise turn their ecosystems into problematic situations. It's really like this combination of cherishing something that is really hedonistic, but really acting in a net positive, sustainable way, which then also basically lays the groundwork for a subject that we've also written a book in the past years, is basically how we can generate regenerative businesses that not only kind of try to be at least a bit sustainable in some senses, but really like focusing on a net positive footprint or handprint with regard to kind of reunifying ecosystems, natural ecosystems and business ecosystems in a way that it's kind of synergetical for both of these spheres, and not extractive, meaning business being extractive and in a negative way extractive. So really like bringing these two systems in a new synergy with new business models. And that's also, this is only an outlook, because I obviously could also talk another 2 hours about this new project that has become into existence roughly 3 years ago now, starting with a very deep research project with regard to processing of certain fish species that kind of produce overpopulations within Germany, but also in terms of other species worldwide, and really like open up the perspective coming from invasive species being the tip of the iceberg, basically, with regard to overpopulations of certain species in ecosystems, where there's a lot more potential, basically a lot more problems to be solved in a culinary way, some of them at least, when it comes to just any species that through changes in ecosystem produces overpopulations. And we could the best thing we could do about it in terms of rebalancing ecosystems into a healthy, thriving ecosystem would be to kind of really selectively eat these certain species that overpopulate. This is an outlook, and well, I would love to join the discussions also afterwards. I wish you all a good time and fruitful discussions on this very important subject. Feel free to reach out on LinkedIn. I'm there at Lukas Bosch, or you can also find HolyCrab on Instagram. Feel free to connect. Feel free to reach out. I'd love to discuss with you all, and yeah, have a good time. Thank you so much for your attention.
Time, sorry. Yeah? It's a coffee break time, and then the second topic. Yeah. Well, thanks everybody for attending. We're a small select group, but I found these papers and discussions really, really interesting and forward-looking. So have a quick coffee and come back for more exciting stuff.
Hello, everyone. Welcome back. It is my great pleasure to start now the second part of the innovation team. Now the subject will be from waste to value, circular innovations in food and agriculture. So I will start now right away with my talk that will be about the bioefficient production of alternative biomass within a sustainable bioeconomy. So first of all, yeah, I'm Luma. I'm here today representing ATB. We are the Leibniz Institute for Agricultural Engineering and Bioeconomy located in Potsdam. So I think there's no better way to start this talk than right away come for the most spicy and worry topic. That is the global society and environment challenge that we are facing. As many of you know, maybe this in 2009, this was the first time that the planetary boundaries, they were published. And they are scientific framework that defines the 9 critical, the critical Earth system process that regulate the stability and resilience of our planet. And the thing is, unfortunately, as we can see, 6 out of the 9, it was already exceed. So this means that we are no longer in the safe operational zone. And as we can see, exceeding this boundary, we are just pushing the Earth system beyond its stable state, and we're going to increase the risk of irreversible and abrupt environment changes. And we don't need to go so far away to remember what's happened here in Brazil, for example, in 2023 and 24 in Rio Grande do Sul with the heavy rains, the floods. We have a tornado last week. Yeah, we also have a lot of cities experience 40 degrees C with the thermal feeling up to 50 degrees C. So the thing is, the more the planetary boundaries that we exceed, the higher the risk of the destabilization of the Earth's life support system, threatening food security, water availability, biodiversity, and others. And I think there's many of you here that work directly or indirectly with food. In my case, I'm a food scientist. So for many of you, we need to know that we are responsible somehow of this. Since food system, they are responsible for 1/3 of the global greenhouse gas emissions. Among a lot of others, we have carbon dioxide, methane, and nitrous oxide as the most important one in terms of their global warming potential. And in a very simple words, these gas, what they do, they trap heat around the planet, and we just experience this later as the higher temperature. And then this brings us to the food system, also bring us to the food paradox. Because first of all, we have the world population being expected to reach up to 10 billion of people by 2085. So this means that we need to produce more food. Now we need to feed these people. But on the other hand, how can this be that we have still 10% of the world population experience of food, hunger and malnutrition, and still almost 40% of the population suffering with overweight and obesity? So to meet this demand, producing more food for the expected higher population by 2080, this means that we need to expand within the same finite land, because the planet will be the same, the arable land that we have, at least now, will be the same. I know that there are people who think that with the climate change, we're going to have more places to produce, but I think in general, we're going to lose. So, and from all this food that it's been produced, we also need to have in mind that approximately 30% of everything that is produced is lost. So here, for example, we have the organic waste, animal manure, and the management of this organic waste is today a major global challenge, since almost 70% of them are just disposed in landfills. And this means later, as a consequence, we're going to have the composition of the organic waste into methane, as we saw, is a greenhouse gas, 28 more dangerous compared with, for example, the carbon dioxide. So why alternative biomass? I think the previous slides a little bit answered this. First of all, they are generally considered better option than the traditional biomass, fossil fuels, due to its potential to reduce the environmental impact and, as a consequence, increases the sustainability. And this will, of course, also contribute to the circular economy. It's a product that often has a high nutritional profile and a lower environmental impact compared, for example, with livestock production. So to have the circular economy, we need to have in mind that this is a model of production and consumption that involves sharing, leasing, reusing, repairing, refurbishing, and recycling existing materials and products as long as possible. And as a great example of alternative biomass, we have insects, the great insects. So why should we still eat? Should we eat insects, or why should we still keep researching them? Well, we know, as mentioned before, we have this situation of the increase of the world population, and then we need to increase the food demand. But as mentioned, we need to produce more with more quality, because we, as a consumer nowadays, we also expect products with more quality, but we think less land and also aiming at low environmental impact. So in terms of environmental impacts, insects already showed great results, since they need 2 times less feed than poultry, 4 times less feed than pig, and up 12 times less than beef. And if we compare this with the land, this is even more impressive numbers, because they require 3 to 4 times less surface area than poultry, pigs, and up to 15 times when we compare with beef. In terms of the global warming potential and land use, as we can see in this case for the example of the mealworms, we have very great numbers compared with milk, pork, chicken, beef production. However, on the other hand here, we can see that for energy use, we still need to keep studying, look for alternatives, because the energy use is higher, can be higher than milk and chicken, but still smaller when we compare with pork and beef. This because to hearing insects, we need control temperature. In this case, for example, for mealworms, we need temperatures around 27, 28 degrees C. And then if we think about a place like Brazil, for example, that is way more hot than here usually, and then we would have to work with refrigeration, and that is also very expensive when we compare this just in terms of the energy use. So the insects, they should be seen as a natural bioreactor. Here in their gut, we have different enzymes, insect enzymes and microbial enzymes, that can convert waste material, what is just considered as a trash, something to be disposed, into valuable products. For example, animal feed, fertilizer, biofuels, and other biomolecules. And if they are so great, can maybe insect use animal manure? Could we use them to feed insects? Well, yes, we can see this. This was a research from our group. We use fresh aquaculture waste. There is a product that comes either from here. First, this will be filtered, because here in this tank, imagine there will be a lot of fish. There will be remaining of the fish feed, the fish excrement, and then this will be, usually this is just fermented here for some months, and then this is also used for fertilizer producing. But we use, in this study here, up to 100% to compare, and we observe that up to 75%, the insects show a very great result in terms of the development, in terms of survival rate. So, very interesting also result here. This is not made by us, but this was a very nice study where the authors, they took the black soldier fly larvae and they exposed them to pig manure, pig excrement, and commercial diet. That was just like a plant bioproduct, what it's usually commercially used for insect production. And what the authors observed, that from all treatments, the larvae choose by themselves just to use the pig manure as a source of feed. It doesn't mean that they doesn't like the commercial diet. I think this is just because their hypothesis it was about increase of microbial diversity in the substrate, pH, and the chemosensor signs of this substrate. But it's also very interesting results. But keep in mind that in Europe, Australia, and North America, it is not allowed to use animal manure to feed insects. For example, because in Europe, they are considered farmed animals. So we cannot feed animal with animal. And this is something that it was even more, it becomes more complicated after that period we have that mad cow disease because of the prions and all the things. This was something that became even more restricted. But on the other hand, in Asia, South America, and Africa, we can use animal manure to feed insects. In terms of the microbiome, this is also very interesting because as I was talking about the gut of the insects, there are a super richness amount of different genus and microorganisms, and as well as you can see here, a high amount of this natural contamination. But no panic, because we also can see and prove that with the adequate conventional or innovative thermal treatments, or maybe not non-thermal, we can offer safe products also by insects. We see here, for example, comparing with this untreated crickets, we have up to 9 log. This is really a lot. And then we could inactivate up to 8 log here. Another very interesting study from our group, it was using Falas. Falas is this bioproduct of the hearing insects. It's everything that left after you take the insects. You'll be also insects excrement, insects that are just died, or part of the insects. And then we use this to produce biofuel, bioethanol. And then as you can see here, when we compare this just with the traditional sugars that is used for the production of the bioethanol, we observe a really considerable increase in the production of the ethanol, also showing another great possibility to do with this insects and insect byproducts. So we have already a lot of insect products in the market. We can see protein bars, oils, vodka, alcoholic products, snacks, just the whole crickets, pasta. But we also need to have in mind that the consumer acceptance in Western countries still remains low. First of all, food neophobia, the fear or reluctance to try unfamiliar foods, but also cultural habits. No? So overcoming this barrier is still our main challenge, to integrate insect-based foods into the Western diets. Take-home message, I would like to have your attention. First of all, that feeding a growing population requires a smarter use of resource. And insects, by thousands of research, has already proven that they can be bioefficient, used as a biomass, converting low-value material into high-quality products. And through sustainability and circular production system, this biomass can also become a key pillar of the bioeconomy, like some of people already is using the term fly economy. Also have in mind that innovative and conventional process, they are required. As we know, we cannot, for example, as a cattle, we cannot remove the intestine of them because, imagine, it's very small. But we can inactivate them. We can make them safe with the proper process. And last but not least, insect-derived food contributes to a healthier diet and a more resilient and sustainable food future. I would like also to take this opportunity to invite all of you to come to Berlin in 2027. We're going to have the Insects Plus International Congress. It's a great opportunity to know more about insects, but not only insects, as well as another alternative biomass. And thank you very much. Muito obrigada pela atenção de vocês. Se vocês tiverem dúvidas, questions now or in the coffee break, yeah, I will be happy to answer or to try to answer them. Thank you very much. Well, all these products that I showed, they are not from, at least not not from Europe. I never really see them. You mean in terms of security? No, yes, it's they some of them has really a lot of insects. They show, for example, here, whole roasted crickets. It's not, we cannot see here, but like it's crickets, dried crickets. In this case here, they just use ants, but they are also here. I forgot to mention briquette sausage for the Germans one. Maybe this might be interesting. Yeah, but yeah, there are a lot of companies. But actually, this one here we have in our lab. But there's also a lot of companies that they just don't exist anymore. Either the market was not good enough, so they just closed. Yeah. Yes. That's healthier. Yeah, it's because, yeah, I think this is more related because first of all, people think that they are, and I also include myself in this, that it's not hygienic, that it's like yes, maybe, I don't know if you compare, for example, the maybe in this context, for example, if you compare just with, I don't know, fast food or whatever that people eat a lot, because the proteins of then this, unfortunately, I forgot to mention or put on a slide, just showing, for example, the nutritional profile of them. Maybe so, maybe not healthier, but healthy could be also that you mean not healthier than something, but a healthy product. Yes. Pode. Ah, ok. Como se fosse granulado, né? Sim, sim. This mentality, yeah. First of all, onde foi esse evento? Ah, ok. Interessante. Obrigada. Yeah. But here from the audience, quem já experimentou inseto? Quem já comeu? Yeah. Yeah, yeah, yes. This would be my answer. So no, it's all of you guys already tried. Yeah, there is, I think already FDA already mentioned some numbers that we will, up to the end of our life, we will eat up to 1 kilo of insects. For the ones who drive motorcycle, for example, we eat when we are sleeping. Guava, goiaba, sim, o famoso bichinho da goiaba, esse aí, proteico. Sim. Tanajura, sim, é muito comum em Minas também. Como eu pude esquecer da tanajura? Yes, yes. Yes, yes. There is, I think, farofa de tanajura. Yeah. Yeah, yeah. This is also part of we're going to talk later about the digital gallery, but just as a small, brief mentioning what is already, because we have to create some ideally future situations of each of our research. And mine was like insects, eat them or starve, but was in a very pessimistic situation. Yeah, but I mean, you see all these people, Instagrams around the world when they go to Asia, what they do, spider, scorpions, but they're not insects. Okay, just to let you know. Yeah. Okay. So yeah, this was and a coffee break. I mean, I don't recall now the name, but I know that I have a colleague who also did his PhD with insects. And then he was telling me that he did an Amazon experience, but he's from Rondônia. And there was a place where you could take from a fruit for something, you could take the insect, you just open, they were still moving, they were super white, and you just eat them. Yes. Yeah, I mean, yes. I just say, well, brave. Yeah, but now we're gonna listen more about insects. I would like to invite now to the stage here, please, Franziska Schindler. She works in Hermetia Barut, also an insects company, and she will give us more insights about this. So, the floor is yours.
Okay, thank you, Luma. Yeah, also to mention a previous question about the labeling. So you have to label what is in there, also that insects and which insect species. There was, I think, 2 years ago, a huge campaign. It was in a newspaper, and all people were afraid that we are mixing some insect flour into breads, but this isn't the case, and this will never happen, because you will always, so as insect meal or flour is more expensive than wheat-based products, you will label it to show, okay, that's something special. Okay, so let's start. Yeah, so Luma already introduced the black soldier flies, so let me introduce our the company history. So everything started with Katz Biotech company. So we are the biggest producer of biological pest control in Germany. So we are experienced in rearing a lot of insect species. And then I think it was in 2005, Naturland requested us to rear the black soldier fly, to use it as a protein source. So then, we started. It wasn't that easy at the beginning, because, you have to find out what you need for the reproduction. So then 1 year later, we founded the company. And then in 2012, we founded our umbrella organization, IPIF, International Platform of Insects for Food and Feed. Then 2 years later, we put production on a ton scale. And since 2023, we built a cooperation with Fruzem. It's a company from Israel, and they developed a technique to increase the shelf life of the small larvae. So thereby we drive the segmentation of the market, because from now on you can buy the baby larvae and you don't need to do the reproduction on your own. So it's like in the pig industry or poultry industry. So there are companies doing the reproduction, selling the baby larvae to companies who are only doing the rearing and processing. Yeah, so we are doing, we have the production site in Barut, which is located in Brandenburg, and south of Berlin. So this is our plant. Sorry. We use excess heat from a nearby biomass plant. This is very important because, Luma mentioned we need some energy to heat the baby larvae. They need some heat at the beginning of the cycle, and this is very energy intense. So there in the second picture, here you see these are our bioreactors. So we're working with tables, and this is the reason why we don't use so much land, because we can use vertical farming systems, and thereby using the height of our bioreactors. These are the fly cages. We also call them love cage because there they reproduce and we use it to collect the eggs. We're also doing a lot of research. So here are some projects, but yeah, there's not enough time to explain them all. Yeah, so black soldier fly is we have a holometabolic life cycle. So we have an egg, we have a larvae, and then the morphology of the animal changes when the adult fly hatches. So it's no pest. It came from tropical regions from South America. You also find it now in Europe. So there are some places where people found it in the south of Germany. And the adult flies don't eat anything. So they only consume some water, then they lay some eggs, and 1 week later they are dying. So they can eat a lot of organic material. So also, we heard about manure. So they can live in a very harsh environment, and they grow very fast. So they gain 8,000 times of their weight in 2 weeks. And this is also very specific for black soldier fly. There are other insects like the crickets or the mealworm. There we need wait to or rear them 4 to 6 weeks. So here we need only 1 to 2 weeks. And we have a very efficient feed conversion ratio. So it means we need only 3 kilograms of dry feed to get 1 kilogram of dry insect material. So this is the best feed conversion ratio compared to other farmed animals. So yeah, how does it look like? So here we have the adult fly. We use some cardboards with some small holes. So the females lay their egg clusters in these holes. Then after 2 to 3 days, the small baby larvae with a weight of 18 micrograms are hatching. After 1 week, we have the young starter larvae. And after another week, we can harvest our mast larvae, which is then devitalized and processed into protein flour. Some larvae are reared longer for 1 week to obtain the prepupa and the pupa, which is then used for the reproduction cycle to get adult flies, which are then used to produce the eggs. Yeah, so this is our main product, the mast larvae. They're really rich in protein, so 39% of protein, 35% of fat. And yeah, now we can see for what we can use it. So the insect protein contains all essential amino acids. We can use it as feed for farmed animals, for example, aquaculture. So it's the best replacement for fish meal to use in aquaculture. So we also did some research projects where we used it for shrimps. They replaced 10% of the fish meal. We can also use it for poultry and pig. We have the approval in the EU to use the protein, for these, so for feed for pet food, aquaculture, pig and feed, but not the whole insect itself. And here you see a picture of a dried larvae, which is then defatted. So this is the defatted protein press cake, which is then milled into the protein flour. So beside feed, we can also use it for food, but there we have to take care of the novel food regulation. And yeah, since now there is no novel food application, and you should know novel food means, or you need to apply for novel food when let's start again. Novel food is food which is not consumed in a significant manner before 1997. So since insects weren't consumed in the EU, there is a need to make a novel application. So this was done for some species, so the yellow mealworm, locusts, and crickets, but not for the black soldier fly. Yeah, and the fun fact, also locusts are kosher and halal. So these are the only insects which are kosher and halal, because I think because of the plague, and there was a need to eat and consume them. Maybe there was also no alternative, so yeah. There are also technical applications for the protein, to use it as a coating, or to use it as a film, also maybe as a protection for food. So then we also have the insect fat, which can be used also as feed. So it's very rich in saturated poly fatty acids. So it can be compared to coconut oil and palm oil. But we can also use it for a lot of technical applications. So for biofuel, or also lubricants. And yeah, sorry, so the picture for the insect fat is missing. So in one research project, we developed the first biodegradable insect-based lubricant. And we tested this lubricant in bicycle brakes using a gene test. And we were able to show that our lubricant, which is biodegradable, passed this test compared to a mineral oil-based product which failed. So this is very important, because yeah, sometimes you need lubricants for equipment outside in the forest. So there, the insect-based fat or lubricant is a sustainable alternative to mineral oil-based lubricants. So when we rear the insects, we also have the frass. So the animals live in their feed, and then when they consume the feed at the end of the process, there are some remaining leftovers, so nutrients, some food, but it mainly consists of excrements from the insect. And this is a very good organic fertilizer. But there are some regulations from the EU that we have to sanitize this frass before it can be used. So we have to treat it for 1 hour at 70 degrees. So now they changed it, so we don't have to do it on the production side, but we have to find a company who's doing that for us. Also, when we use it, want to use it as a substrate for biogas production. So we have to find a company or a biogas plant who is able to reach 70 degrees for 1 hour in their process. But you see here, so here we had a research project, it's called INVERT, so the insect biorefinery. And there we used supermarket leftovers, so without fish and meat, and with fish and meat. So everything which was not salt was used. So bakery substrates, then also vegetables, fruits, milk products, dairy products, and meat and fish. And we first analyzed the feed for its biogas potential, and then took this feed to rear the insects on it, and analyzed the biogas potential of the frass at the end of the process. And we found a very similar biogas potential. So, maybe I come later to this point. So it's a very sufficient substrate for the use of the in the biogas production. So now I highlighted the application of the black soldier fly, but now the question: okay, what does they eat? We learned, okay, they can also eat manure, but as the insects are considered to be a farmed animal, they cannot, or we are also only allowed to feed certified feeding or certified substrates. So also for the purpose of producing technical products out of it. So it doesn't matter for which purpose you rear insects, you have to use certified feeding materials. So there is an example, for example, for few animals. There it is allowed to also feed fish and meat, but not for the black soldier fly or insects overall. So yeah, what is allowed? It's allowed to feed wheat-based material, but I think it's not. Yeah, it doesn't make any sense because then we are in concurrence with crop for food. What we are using is agriculture byproducts, which you see. Oh no, sorry. I thought I also introduced, put an image from okara, which is a side product from tofu production, but also the food production byproduct. So yeah, like this okara, or maybe when they produce some donuts, which don't have a hole. So we learned there are 30% of waste along the production chain. So it's a lot of waste, and some waste, or maybe let's not call it waste. Let's call it side products. And some side products can be used for other farmed animals. So for example, here a lot of bakery leftovers can be used to produce dry feed for pig and poultry. But most of the wet side substrates, also like vegetables and fruits, cannot be used. And yeah, here you see what is happening. So this is our current circular system. So we are producing crops to get food, or using crops to feed it to farmed animals, to produce dairy products, and then a lot of the leftovers is going into biogas plants. So at the end of the day, we are burning nutrients to get heat and power. So at the end of the process, what is the leftover from the biogas plant is also used as a fertilizer to go back into the system, but the system is very inefficient, and we have a loss of nutrients. So what we claim is using the leftovers. So this is allowed to use vegetarian leftovers, so vegetables, fruits, and dairy products, to feed the larvae and to obtain protein and fat for pet food or use it for farmed animals. And then using the frass, because I showed you 2 slides before that this is a very potential substrate for biogas plants. Use this as a substrate for the biogas, or use it directly as a fertilizer. So yeah, there we have multiple usages. We are not in competition. When we want to replace mineral oil-based products, we always use like RAPs. Yeah. So we use crops for the production of technical products. So using the black soldier fly fat is a good sustainable alternative. And this is what we are also working on. because you have to exclude fish and meat. But this is not that easy, because when you get a tonnage and all the leftovers from the supermarket, it's all mixed in one bin. So you have to separate, and the authorities, they have a 0% tolerance strategy. So at the end, someone is standing there at the conveyor belt and needs to pick out everything which could contain meat and fish. This is not so easy. And also, meat and fish is a very potential substrate for black soldier flies. So we saw that we reached the highest feed conversion ratio with this material. Yeah, and we are working on that we can use these materials, so pre-consumer leftovers with fish and meat to feed our larvae, and that the larvae are going back into the food chain as feed for farmed animals, or to use it for technical products. I think this will be the first milestone, that we get an approval for pet food and technical products, and maybe later when we show that this is safe, and they are working on with the project, it's called Safe Insects 2.0. So it's a cooperation with the University of Wageningen in the Netherlands. There we try to showcase that the usage of these materials, fish and meat, is safe, and driving the approval from the EU Commission. Yeah, and then thank you very much for your attention. Are there some questions? I think it's at the end of the day, we need to get these substrates approved, because it's they have such a high potential. It's also a very high amount of substrates which can be used in this way to retain nutrients and not burning them. So insects are farmed animals, and since the BSE crisis, there's a ban to use animal byproducts to feed animal byproducts to animals. Yeah. So we are working on the idea to making an extra animal group and making something like with the fur animals, so that we have special rules only for insects. Because it's a special animal, so it's not like a pig. And there are substrates, you can give some side products to pigs and poultry, but when you have some spoilage, it's not possible. But the larvae don't care, so they love it. Yeah, so animal welfare is a big topic, but here it's a special case, because we have positive mass production. So the animals need each other. So we have in the box, so which is 60 times 40 times 60 times 40, and we have roughly 8,000 animals in one box. So that's huge, but they need each other. We also performed experiments where we put them in a single animal in a box, and they all died, because they need each other to produce the heat. They need to grow, and also they are cleaning each other. No, we devitalize them. There are several ways. So we are using heat. So we put them at 80 degrees for 1 hour. So then they are devitalized, and then we dry them overnight. There are also other techniques using hot steam or hot water. Or some companies are also using cutting technology. So to produce a slurry, yeah. But at the end, this is the fastest way, and it's very fast for the animals. So it's not like freezing or so they don't have to feel the.
Temperature goes down, their metabolism stops, right? So I would say it's less like profitable for you to release them, or why they use heat instead of breathing?
It's not very economic to cool them down and then to heat them up to dry them, because there are several processing methods. So the dry process and the wet process. For the wet process, you need the larvae wet, so you cut them, and then you separate protein and fat. And we are using the dry method, so we need to dry the larvae to then defat the larvae with a mechanical press. Yeah, but this is very important topic, and there we need some research, because there's not so much known about, okay, does they feel pain? How can we measure it? No, not this kind of experiment, but we performed experiment where we used higher amounts of larvae, but different number of larvae. And at the end, we saw no difference in the survival rate. So this is one key indicator for us, also for animal welfare. But yeah, at the end, when you have more larvae, they maintain smaller because there's less feed for the individual animal. But at the end, there's no impact on the survival rate.
Okay, so thank you very much, Franziska. So now the following talk will be done by Enno Schröder. He's online, and he's also talking about waste, from waste to resource, human excreta, and circular agriculture. Yes, you heard right, human excreta. Hello, Enno, can you hear us?
Hello, perfect. I can hear you. Can you hear me?
Yes. Good.
Perfect.
Floor is yours.
Yeah. Thanks for your interest, and yeah, I'm very happy to be here. My name is Enno Schröder. I'm responsible for the research and development activities of Goldeimer. We are based in Germany, and yeah, my topic is from waste to resource and human excreta and circular agriculture. And on this picture, you already see this year's product. It's a field of buckwheat, and yeah, what is behind that?
You know, I not see it screen. Can you please? Oh yes, now yes.
Say
Thank
again.
you. No, yes, it's okay because we were not seeing your screen anymore, but now it's good.
Okay, perfect. So yeah, on the screen you see a field of buckwheat, and this is this year's product, and what lies behind this product you will see in the next few minutes. So let me start with a little agenda. I would like to explain what Goldammer is, and then talk a little bit about the nutrient crisis, then open up vision, talk about nutrient recycling, and then take you on a little video tour and show you our living lab here in Germany. And then, yeah, last but not least, since it's, from my point of view, the major gatekeeper or the major barrier to that's preventing going to scale with such products, I'm going to talk about legal the legal framework we have here, and yeah, the little outlook at the end. So, what is Goldammer? Goldammer is a social business that was founded in 2014. In the beginning, we were doing festival dry toilets. So those toilets, which you can see here on the top picture, toilets here, the queue there. We are doing that on festivals, and we are still doing that since over 10 years. And then after a few years, we invented a social toilet paper, which you can see over here. It's a toilet paper which is recycling, but it's also communicating. There are little informative illustrations and jokes on the toilet paper, and also the packaging is informing about our work, about nutrient cycles, about sanitation topics globally. Then, after even a few years more, we came up with an online shop. There's a screenshot you can see over here, and it's yeah, totally around sustainable sanitation products. So we have dry toilets, which you can buy there for allotment gardens or for camper vans. And then in this picture, you see something I'm very proud of. And it's actually the vision we already had in mind when we started our first festival toilets in 2014. We wanted to compost the feces that are collected there. And this picture here shows the recycling facility we are now operating since January this year. And we are composting in a two-step process human excreta there, so feces, and it was realized in as part of a European innovation project, which is called P2Green. So let me talk about the nutrient crisis. Before jumping into the picture and the bullet points itself, I briefly want to explain the concept of plant nutrition. So, as you probably all know, plants need nutrients to grow. Humans eat that food and actually excrete the nutrients again as urine and feces. So very, very short. So now in current linear sanitation systems with flush toilet and sewer system and treatment plant at the end of the pipe, ideally, there is a loss of such nutrients, and 90% of such, up to 90% of such nutrients, so namely nitrogen, phosphorus, potassium, are lost in that kind of conventional linear system, a sanitation system. So now, what is happening in conventional agriculture? On the other hand, nutrients are like to keep up soil fertility. Nutrients come to the field, and they are from synthetic mineral fertilizers. So produced in several processes, harbor Bosch, or they are mined when it comes to phosphorus, and phosphorus mines are sometimes in autocratic regimes, so not the easiest solution there. But the funny thing is, or the interesting thing is, with nutrient recovering sanitation systems. So, for example, the systems we are seeing in the next slides, it's possible to substitute up to 25% of those synthetic mineral fertilizers with human resources, so fertilizers from urine and feces. And I had a little conversation with AI about it, and this is actually the picture that was spit out of the system. And yeah, it pretty much, I mean, it's way over top, but it pretty much shows what are all the connections. Now, talking about a positive thing, the vision, which is nutrient recycling. Let me briefly explain the concept behind it. So this picture you see on the top of this slide here shows a city, which is like a densely populated area, which is an area of nutrient surplus. And we have over here an area of agricultural production, it can be rural area or peri-urban area, and it's an area of nutrient demand. So now the idea is to take any kind of bio-waste, also urine and feces, and transport it out of the city and have some kind of recycling with appropriate recycling technologies, remove pollutants and bring the nutrients and the carbon back to the plants. Grow food, and the food goes back to the city and can be consumed again. So that was very conceptual, but how could that look like in reality? On this picture here, you see a classical source separating toilet. So over here in the front, you have a urine collection, and on the back, now there's a lid, but when you sit down, the lid opens and the feces are collected there. And instead of having a treatment plant at the end of the pipe, now the recycling technologies we have here are for the feces, such a recycling composting facility you already know from one of the previous slides, the one we are operating with Goldammer. And for example, the urine can be treated and recycled in such a plant like this. It's from the company called Juna Nexus, a very interesting concept, producing a liquid fertilizer out of urine, which is called Aurine. And one thing all those fertilizers and the recycling technologies have to have in common, they have to assure safety, they have to be hygienic, and they have to be beneficial to plant growth, and of course, practically applicable in agriculture, meaning farmers can work with that. So now I want to give a little video tour about our facility, and I think it takes about 3.5 minutes, and it has English subtitles, so you should be able to follow. Thanks.
Hi, ich bin Enno von Goldammer und das hier ist mit dem hier untrennbar verbunden. Daran erinnert uns die Natur jeden Tag. Dass aus Essen nach der Verdauung Kacke wird, ist aber nur der eine und meiner Meinung nach auch der langweilige Teil der Geschichte. Der eigentliche Zauber kommt nach der Verdauung. Denn irgendwann wird wieder sowas draus. Im Grunde genommen wurde alles Lebendige um uns herum schon unzählige Male gegessen, verdaut und wieder ausgeschieden. So funktioniert die Natur seit Millionen von Jahren. Seit ein paar Jahrzehnten jedoch reißen wir ein Loch in diesen wunderbaren Kreislauf und spülen die wichtigen Nährstoffe aus unseren Hinterlassenschaften einfach so das Klo hinunter. Diese sind dann quasi verloren. Wenn wir zukünftigen Generationen aber nicht die Lebensgrundlage entziehen wollen, müssen wir das Klo als Teil des Kreislaufs betrachten und nicht als Endstation. Das klingt nach einem langen Weg und viel Veränderung, und das ist es auch. Aber irgendwo muss man ja anfangen. Und wir von Goldeimer, wir fangen hier an. Auf unserer ganz besonderen Recyclinganlage in der Lüneburger Heide. Sie ist Teil des EU-Innovationsprojektes P2Green, das zum Ziel hat, die Sanitärwende in Europa voranzubringen. Hier verwerten wir menschlichen Kot, den uns tausende Festivalbesuchende auf unseren Trockentoiletten gespendet haben. Die Leute finden es immer ziemlich spannend, wenn wir erzählen, was an Trockenklos so toll ist, wie sie einen Beitrag zur Lösung globaler Herausforderungen leisten können und warum wir dafür ihre Kacke brauchen. Die gesammelten Kackespenden werden nach dem Festival zu unserer Recyclinganlage transportiert und dann geht's an die Verwertung. So, als erstes kommen die Trockentoiletteninhalte jetzt hier in diesen Hygienisierungscontainer. Und zwar werden die hier abwechselnd mit Stroh eingefüllt. Also im Prinzip so wie bei einer guten Lasagne. Deckel zu, Belüftung an. Und jetzt gehen die Mikroorganismen an die Arbeit und zersetzen das Material. Durch ihre Aktivität werden Temperaturen an die 70 Grad erreicht und nach einer guten Woche ist das Material hier drin hygienisiert, also alle Krankheitserreger abgetötet. Nach der Hygienisierung sehen die Trockentoiletteninhalte dann so aus. Fertig ist das Material so natürlich noch nicht. Weiter geht es in der Kompostierung und zwar wird da noch die gleiche Menge an geschreddertem Grünschnitt hinzugefügt. Das ist Material hier aus der Region. Und um die Kompostqualität dann noch weiter zu steigern, haben wir hier noch Pflanzenkohle, hier vom Hof aus eigener Produktion. Und das zweite ist, dass wir Bentonit als Tonmineral hinzufügen. Das geht jetzt in den Kompostiercontainer. Die Schnecke vermengt das Ganze und gräbt es ordentlich um, sodass das Material Stück für Stück kompostiert und richtig schöner Dünger daraus entsteht. Der Kompostierprozess dauert nun noch 6 bis 8 Wochen und am Ende wird das Material einmal gesiebt, um Fremdstoffe und Störstoffe zu entfernen. Und dann geht es ab ins Labor. Hier wird auf Nährstoffe, Schadstoffe und solchen hygienische Parameter untersucht, um wirklich auch sicherzustellen, dass das Material unbedenklich ist und als Recyclingdünger ausgebracht werden kann. Und das zeigen wir auch in der Praxis. Auf dem Gelände hier führen wir einen Feldversuch durch, um neben den Laborproben auch auf dem Acker zu zeigen, dass der Dünger unbedenklich ist und Boden und Pflanzen davon profitieren. Wissenschaftlich begleitet wird der Feldversuch vom Leibniz-Institut für Gemüse- und Zierpflanzenbau. Noch darf man auf Recyclingdünger aus menschlichen Fäkalien nichts anbauen, was später mal auf dem Teller landet. Doch da wollen wir natürlich hin. Wir wollen den Kreislauf wieder schließen und ihn greifbar für die Menschen machen. Wir sind davon überzeugt, die Zukunft der Toilette ist zirkulär, wasserlos und dezentral.
So, can you still hear me?
Yes.
Perfect. Just to sum it up a bit, you saw our facility and you saw that we are producing a compost out of the feces we are collecting at festivals, and everything we do there is lab tested and totally safe, hygienically not a problem. We only then, when we have green light of the lab tests we can apply that in field trials. And I'm stressing that fact because it's really scientifically proven that such treatment technology we are doing, but also others are doing with similar concepts of nutrient recycling from urine and feces. It is working, it's safe, and it's beneficial for plant growth. And with this slide, now I want to focus on the legal framework, which is, from my point of view, the main barrier of marketability and of really going to scale with such kind of products. And there are different levels which could be interesting, but since we are now working on a European level with the P2Green project, I want to focus with a few bullet points on the so-called European Fertilizing Products Regulation, so FPR. And it's the regulation that defines which fertilizing products may be placed on the European market, receive CE mark, and can be circulated. And in that FPR, there are so-called component material categories, so CMCs. It's basically defining what kind of input you can use for a fertilizing product. And nowadays, human excreta-derived materials are not yet included in any kind of the CMCs. There is a CMC for compost, for example, but it's not. But it's excluding human excreta. So, to be able to have a broad market entry for such products, it has to be able to comply with the FPR to receive the CE mark, and one of the ways for this is that there would have to be an inclusion for a new CMC, like CMC 17 or 18 treated human excreta, or existing CMC, for example, CMC 3, I think it's number 3 for compost. And the interesting thing is right now, those FPRs, they are existing, or those regulations, for example, like the FPR, they are existing for a period of 5 to 10 years, let's say. And in very frequent intervals of maybe 3 to 5 years, there are amendment situations. And right now we are facing such an amendment situation. And now it's very interesting to take that opportunity and to show that, or to give scientific evidence of safety and to prove the agronomic efficiency. And that's different to the national level, so the German level. There's this very similar thing on the German level to show international market relevance. And this is basically the set of requirements that has to be fulfilled to prove that it is worth to have human excreta as a, for example, new CMC. And this is actually the process we are currently involved in with the P2Green concept. So from my point of view, this is the most interesting thing and most important thing. And now, last but not least, the outlook. It has a lot to do with continuity. I realized when I compiled those bullet points. When we started doing it 10 years ago with the festival toilets, we thought, okay, let's go circular with it. Let's compost it and then sell it as fertilizer. But it's not that easy, as we learned over time. So we realized that continuous operation of such technology options, so be it the toilets or be it the recycling facility, needs to be done to be able to innovate and to consolidate the whole setup, but also to be able to produce scientific evidence. Not only for the fertilizers, also because we need that data for the field trials, and then convince. That's the last point. Convince stakeholders through all levels. So from farmers to consumers, from farmers and consumers, even to EU level departments with those scientific data. And yeah, at the end of the day, when we started thinking about it, we thought maybe when we started thinking about the festival toilets and composting it in 2014, we thought maybe we need 5 years to have that process running. But now, more than 10 years later, I still think it might take 5 years, and I'm pretty sure that in 5 years, I might say a similar thing, but I think we are on a good way. And yeah, we are really enthusiastic about this potential that can be opened here and unlocked. So thanks a lot for the interest and for your attention. And yeah, really feel free to reach out. And I don't know how question and answers are organized here, but I'm available. So thank you.
Thank you very much, Enno. So we would have time for one question. Okay. Maybe you come.
Enno, thank you very much. It's a really nice presentation. Actually, it's 2-in-1. Have you tried to check the legislation for organic amendment instead of fertilizer or soil conditioner? Those are things that the EU regulation separates very clearly. But the interesting question for me, you're collecting all the residues from a festival. I can imagine that the amount of residues of different things that people use in festivals must be very high. What happens with all the microorganisms in there?
Could you hear?
Well, yeah, I understood two questions. One was, why are we only targeting fertilizers? That's what I understood. There could be an option to target soil amendment products or on a substrate level, soil conditioners. Well, since it's all included in the FPR, I think it's the same game. You have the CMC on the one hand, but also you have the PFC, so the product function category, which defines what function your product has to fulfill. So it, depending on the nutrient level, for example, it can be a fertilizer. If it's high enough for our compost, for example, we are just around the threshold of being a fertilizer or just being a soil conditioner. So it depends on how we develop the process and what other ingredients we can insert. And your second question, I understood, was about basically any kind of pharmaceutical residue, right? So substances people use in festivals could be drugs. They are very similar to any kind of other pharmaceutical residues. And the interesting thing is that, well, it has to be said, there needs to be much more scientific approval for this. But the bottom, the conclusion from all the studies that have been done on this topic up to date, the breakdown process of pharmaceuticals is much more efficient in a composting aerobe process environment as in aquatic regimes. So when we have a treatment plant where we have sewage water flowing in and being recycled there, it's much harder to get rid of the pharmaceutical residues there. And there is one study from Germany that says if you want to have the same amount of pharmaceuticals, it's carbamazepine, which is I think it's epileptical medicine. If you want to reach the dose of one tablet, you have to eat 500,000 white cabbages, which are fertilized with such kind of recycling fertilizers. So it really gives an idea of how the passage of or how the movement of pharmaceutical residues happens from soil to root to plant to edible food. So I hope that that answers your question a bit.
Thank you very much, Enno, for the super interesting presentation, and all the best for you in the regulation and the legislation that you need to overcome. Thank you.
Thank you.
So now I would like to invite Marileide Moraes Alves for the next talk, Technologies in the Recycling of Waste from the Food Process Industry.
Boa tarde. Coloquei os slides em inglês, mas vou apresentar em português. Me sinto mais à vontade. Eu trabalho com uma demanda local que não é exatamente uma indústria, mas uma produção de alimento feita em nível doméstico. Porém, eu coloquei indústria porque não deixa de ser uma produção de alimentos. Então, a indústria que eu faço menção é uma comunidade que sobrevive da extração de carne de caranguejo. São duas comunidades que nós temos em Bragança, a comunidade do Treme e a comunidade de Caratateuá. E essas comunidades, elas produzem alimentos de forma que impactam bastante o ambiente local, comprometendo a qualidade de vida. Então, como surgiu essa demanda? Existe dentro dessa cadeia produtiva o impacto que, além de ser pela questão do depósito de resíduos no ambiente, existe uma questão social, onde há mão de obra de mulheres e crianças e em condições precárias de higiene. Aqui é uma foto do entorno da comunidade. Então, a gente pode ver que esse resíduo ele é descartado em área de mangue, de manguezal, e esse resíduo contamina a água de superfície, a água do lençol freático e ocasiona... Esse resíduo é uma foto que foi tirada no leito do rio que banha, que serve a comunidade. E além do comprometimento socioambiental, eu listei aqui várias situações em que esse comprometimento é bastante visível. Por exemplo, a comunidade ela sofre muito com a saúde laboral. As pessoas que praticam essa atividade, elas têm cortes na mão. Crianças acordam 3 horas da manhã para que possam praticar a atividade e ir para a escola apenas no turno da tarde, voltando já com o físico completamente desgastado. Então, o rendimento escolar ele não existe pela condição sacrificada que essa criança e as mulheres são submetidas. Eles têm muitos problemas de respiração, porque como o resíduo é em uma quantidade muito alta, muito grande, no próximo slide eu vou mostrar para vocês que dessa atividade só se aproveita 25% do que é comercializado, 75% é resíduo. Então, o que eles fazem? Eles tentam, por conta própria, destinar esse resíduo. Como? Queimando. Só que, quimicamente, esse resíduo não é adequado para uma queima. E aí há a produção de gases, CO2, metano, todos os gases tóxicos que vocês possam imaginar decorrentes dessa tentativa de combustão desse resíduo. Então, é muito comum você encontrar pessoas com problemas respiratórios. O que não é destruído fica acumulando água e isso desenvolve vetores de malária. Houve um surto de malária por conta da proliferação de mosquitos, dengue, proliferação de vetores como baratas, ratos, moscas, são muito comuns dentro da comunidade, que inclusive afetam a qualidade desse alimento que é produzido e que consumidores acabam tendo o comprometimento da segurança alimentar. Leptospirose a ratos, né? A ratos, hepatite, que é transmitido através de baratas. Tudo isso é muito visível dentro da comunidade, porém, a prática continua porque não há outra alternativa de renda para sustento. Na foto anterior, vocês viram o depósito, então aquela ali é uma imagem que fala por si a respeito da contaminação das águas de superfície e do lençol freático utilizado por essa comunidade no abastecimento de água. Como eu havia falado antes, do que eles comercializam, apenas 25% é aproveitado para a geração de renda e 75% é um passivo ambiental que causa toda essa problemática que eu já explanei. Eu trabalho no laboratório de tecnologia do pescado e, observando a minha formação em engenheira química, observando toda essa demanda, todo esse passivo ambiental, eu procurei fazer pesquisas que possam minimizar esse impacto. Então, uma delas foi a produção de fertilizante para feijão, já que na região há uma produção de feijão. Comida para frango e peixe e biogás. Esse resíduo ele é separado em duas porções, basicamente. A parte do exoesqueleto, que é rica em cálcio, e a parte das vísceras. Então, para cada uma dessas porções, eu trabalhei em uma linha de pesquisa diferenciada. Vou voltar um pouquinho. A parte do exoesqueleto, nós temos já bem consolidada a produção de blocos pré-moldados para construção, pode ser tijolo, estacas de concreto. E, ultimamente, nós estamos trabalhando com uma tecnologia que é mais, tem uma característica mais social, realmente, que é a produção de composto para utilização em culturas de curto ciclo. Estão entendendo bem? Sim? Esse aqui é um dos experimentos que eu fiz. Nós fizemos uma espécie de fermentação de todo o material. Nesse momento, nós incluímos tanto o exoesqueleto como as vísceras. Utilizamos o método de silagem para que esses nutrientes fossem quebrados quimicamente, fossem mais passíveis de absorção pela planta, e fizemos esse experimento com o feijão, como eu falei para vocês, já que é uma cultura que existe no entorno da nossa região. Fizemos também um complemento alimentar para frangos, sem o exoesqueleto, porque uma vez que ele é rico em cálcio, é um fator antinutricional. Então, nós tiramos o exoesqueleto para que não comprometesse a nutrição dos frangos de corte. Então, isso aqui foi o produto que nós fizemos. Também fizemos uma pré-digestão para que a absorção pelo animal fosse mais potencializada. E aqui foram os nossos testes. Separamos galinhas e algumas nós utilizamos o nosso composto e outras não. Não foi muito bem aceito naquele momento, mas precisamos melhorar essa tecnologia. E também houve uma tentativa de produção de biogás. Houve a produção do biogás, nesse momento também nós separamos o material, porque, mais uma vez, o cálcio que compõe a carapaça, ele atrapalha o processo de biodigestão. Então, a produção de metano foi bastante comprometida quando utilizamos o exoesqueleto. E fizemos a separação e tivemos uma produção de metano mais interessante. Esse biogás, inclusive, ele pode ser feito um scale-up, um aumento de escala. Nós fizemos aí em nível de bancada, mas dentro da comunidade seria passível de aplicação. Então, a comunidade teria retirado do ambiente essas vísceras, que é a maior problemática para eles, teria uma produção de gás que eles poderiam utilizar na cozinha, ou mesmo para geração de energia elétrica, se houvesse aquisição de um gerador alimentado pelo metano. Aqui são algumas fotos do nosso experimento. Aqui são os blocos. Nesse experimento, nós usamos só o exoesqueleto. Nós substituímos a areia por pó de carapaça em 5, 10, 15, 20% de substituição, o que já ajudaria muito na retirada desse material do ambiente e evitaria aquele acúmulo de água que eu falei no início, que proporciona a proliferação de mosquitos, que são vetores de doenças que comprometem muito a comunidade, como malária, dengue. E essa foto aqui é o experimento mais recente que nós estamos fazendo em parceria com o Instituto Mamirauá, inclusive fomentado por uma instituição americana. Nesse momento, nós estamos utilizamos apenas o exoesqueleto para fazer compostagem. Vamos usar caroço de açaí, papelão, a carapaça, e já estamos praticamente lançando para a comunidade esse projeto. No dia 17, agora nós vamos levar a comunidade para conhecer o nosso projeto, para que eles possam replicar. É uma tecnologia mais simples, bem mais simples que a tecnologia da produção do biogás, mas que pensamos será bastante útil, e a comunidade realmente anseia por essa transferência de tecnologia. Considerações finais, todas essas tecnologias que eu explanei, elas estão em nível de bancada, mas elas podem sair desse nível de bancada para uma escala maior e servir a comunidade. O que acontece? A gente precisa de fomento e precisa de elementos dentro da comunidade que tenham essa proatividade de fazer o encaminhamento e a implementação de todas essas tecnologias sociais que estão passíveis de aplicação. Obrigada pela atenção e me coloco à disposição para os questionamentos.
Thank you very much. We also have a time for one question, because we are very delayed. Ração. Ok. So, mais uma perguntinha ali dela. Eu também. Muito obrigada. So, yes. So we have a small situation now, and because of the time, we still need to run the part 2 of the World Cafe. So now I would like to invite you that we go back to the room 1412, and then we will try to do it with 30 minutes. And then we're going to be just 15 minutes delay for the book launch and the innovation gallery. But I think maybe if you reduce the questions, we could do it. Otherwise, there will be no time for the World Cafe, part 2. So please, yeah, no introduction. We know already how it works. You know already where is your seat, just go there. Yes, we would like to do a picture of everyone now, so please come here in front.